Right, next section, fractions, decimals, and percentages. We're going to start with decimals and percentages. Right, so just pause here, have a go at these questions from last time. Right, so with both of these ones, we want to rewrite so the denominator of them is 10. So how do we turn a 5 into a 10? We times by 2, and what we do to the bottom, got to do to the top. So 2 times 2 is 4, 5 times 2 is 10. So 2 on 5 and 4 on 10 are the same. How do we make a 2 into a 10? Times it by 5. Let's do the same thing to the top. So we get 5 over 10. Next question. Rewrite the fractions below so that they have a denominator of 100. So turn 10 into 100, we go times it by 10. Do the same thing to the top. Get 80 over 100. How do we turn 20 into 100? Times it by 5. Same thing to the top. And get 20 over 100. Alright, converting decimals to percentages. So what you're doing here is multiplying the decimal by 100. What that looks like though is moving the decimal place 2 to the right. So you can see down here we've got 0.05. If we get that decimal place and do one skip and then 2 skips to the right, we're left with 5, so 5%. On a calculator, 0.05 times 100, 5%. On the calculator, that was come up as the 5. Right, these following questions, convert the following decimals to percentages. So we've got 0.01. Let's convert that to a percentage. So I'm going to times that by 100, which means I move this decimal place here 1, 2. So it goes just behind the 1, so that'll give me 1%. Next one here, 0.45 times 100. I'm going to get that decimal place and go 1, 2, 45%. 1.5 times 100 for our last one. Now this one, you might have to put a 0 in there. You can put as many zeros past the last number in the decimal as you want, as long as it's past that last number. Move that decimal place 1, 2. It's because of that second jump that I need to put in that extra 0 past that decimal. So it gives us 150%. Right, pause here and have a go at these ones. Same as what we were doing before. All you're doing is timesing by 100, which means you get the decimal place and go 1, 2 jumps to the right, 8%. So 1, 2, 165%. 2, 24%. So it's always just the 2 jumps to the right to convert a decimal into a percentage. And there you have it. Okay, and going back the other way, converting percentages to decimals is the same, just in reverse. So on your calculator, you're going to be dividing by 100 instead of multiplying by 100. And what that looks like is moving the decimal place 2 to the left. So if I want 5% to go back to a decimal, what I first like to do is put some zeros out the front and then go, okay, my decimal place was originally here, so I'm going to go 1 skip, 2 skips to the left. It's going to be there, so 0.05. Okay, on your calculator, 5 divided by 100 should give you 0.05. Alright, let's have a go at these ones. So 50%, I'm going to add a couple of zeros here. decimal place was originally here. We go 1, 2. So if I divide that by 100, that's going to give me 0.5. You can put in that extra 0 if you want. So 0.5, 50%. 3% divided by 100, convert to a decimal. So 1, 2, 0.03. And lastly, 175% divided by 100. So decimal place was originally here, 1, 2, 1.75. Okay, pause it here and have a go at these questions. Alright, so 4%, 4 divided by 100, add the zeros here in front of the 4. Decimal place was there, 1, 2 to the left, 0.04. Alright, with these ones I want you to pause and have a go at doing these ones for yourself. So check your answers, see how you went. Okay, next section, fractions to decimals, so the second half of the lesson. Have a go at these questions from last time. Rewrite the fraction below so that it has the denominator of 10. So just like last time, we're going to multiply the top and the bottom by 2. So the bottom number is going to be a 10. And with this one, we want to times it by top and bottom by 5. So we've got a denominator of 10. These ones timesing by 10, and this one we're going to be timesing by 5. So this one's going to be 80 over 100. This one's going to be 100, 20 over 100. Okay, copy down both of these into your books, converting fractions to decimals and converting fractions to decimals using a calculator. You can pause it and write those down. Okay, this first one here is 4 out of 10. It's already over a multiple of 10. And that multiple of 10 only has 1 0 in it, so that means we're going to move our decimal place 1 to the left. So 4 divided by 10, decimal place was originally here, 1 jump, it's going to be 0.4 as a decimal. Next one here, 3 over 5, we want it as a multiple of 10, so we want to convert that 5 into a 10 because that's easy. We're going to multiply the top and the bottom by 2 to get 6 over 10, and remember 10 means 1 jump, so decimal place was here, 1 jump to the left, 0.6. 5 over 8 is a bit trickier. This one, how I was saying it was trickier, it's probably beyond doing it in your head, so I'd like you to try that one on a calculator. So if you go 5 divided by 8, we get 0.625. Okay, let's convert these following fractions into decimals. Right, these first ones up here are easy enough to do in our heads, or to put as a multiple of 10 and do. These two down here though, these bottom ones, we're going to have to use a calculator for, because they don't go quite as nicely. So the first one's already out of 100. That multiple of 10 has 2 zeros in it, so that means we're going to jump 2 to the left. So 1, 2, 0.7. This next one down here, 10, it's got 1 0 in it, so we're going to jump 1 to the left, 0.4. This one here, got 1 0 in it, jump 1 to the left, bang, 0.9. This next one's not out of a multiple of 10, so we have to multiply the top and the bottom by 2. And now we've got a 10 on the bottom, which is 1 0, so 1 to the left, 0.8. Next two I want you to try on a calculator. So 2 divided by 9, 0.22. And if you actually do this on a calculator, you see that those 2's just run on forever. So sometimes you'll see people put a little dot over the last 2 to say that that is recurring. It just keeps going on and on and on. And the next one, 8 divided by 14, 0.57. And this at 2 decimal places is fine. Okay, next section, fractions to percentages. Right, I'd like you to copy down this section in your book on converting fractions to percentages using a calculator. So you can see here, write down as a division problem. So 3/4, 3 on 4, 3 divided by 4, and then times it by 100. Now, depending on your calculator, you may need to put brackets around that first bit. But have a go at that one, see if it comes out as 75. If it doesn't, try it with the brackets. Right, so let's try these ones. 4 divided by 5. And I'll multiply the whole lot by 100. So if I put 4 divided by 5 into my calculator, I get 0.8 times 100, 80%. I'm going to do that with each one. So that's what makes maths good. If you apply the same rule, then you're always going to be right. So 3 divided by 10 will be 0.3 times 100, going to be 30, put a percent sign on it. And lastly, 7 divided by 9 times 100, 77.77%. And I've made a bit of an error there, because that next one, that last 7, should actually be an 8, because the next number down is a 7, which is 5 or above, so I should be rounding up. Right, pause it here, have a go at answering some of these questions. Right, same rules before. Write down as a division, so 4 divided by 9 and times it by 100. If you put that into your calculator you should get 44.44, and then put your percent sign on the end. Same thing with each one. 11 divided by 12 times 100. 8 divided by 22 times 100. So if you put all those into your calculator, you should get these results. Make sure you're using brackets if you need to. Alright, let's have a look at this one here. This question here looks very similar to a question that was on your test, I'm pretty sure, in term 1. So decimal to a fraction, 0.8. Well, let's turn that into a percentage first. 0.8 to a percentage, we can times it by 100. so 2 jumps to the right, 80%. And as a fraction, we can have 80 over 100, which we can break down to 8 over 10, or 4 over 5 if we need to simplify it. 7 over 10, we can call that 70 over 100, which can be 70%. And as a decimal, we can turn that percentage into a decimal by jumping 2 to the right, so 0.7. Alright, let's do a few more of these. So 0.66 will be 66% if I jump that decimal place 2 to the right. And that's going to be 66 over 100. Next one, 9 over 10 is going to be 90 over 100, or 90%, which if we do the whole jumping with the decimals is going to be 0.9. 50% is a very common fraction, it's a half, or 0.5. The last one, 22 over 50, probably going to have to put that into your calculator to find you get a decimal of 0.44. It's going to be 44%. Okay, word problems. Okay, just have a read over this. If you've got colours, use the colours to write these down in your book as well for the predict, clarify, big question, solve and reflect. Have a look at this one. Which is greater, 0.4 or 45%? First thing you need to look at is, are they in the same units? One's a decimal, one's a percentage. So we need to either put them both as percentages or both as decimals. So 45% is 0.45 as a decimal. So that tells us that 45% is greater than 0.4. Okay, word problem number 2. Jo scored 24 out of 30 on her geography exam. What percentage of questions did Jo answer correctly? So we've highlighted the 24 out of 30, that's the important information. And we also want to know what percentage she got. So write that down as a fraction, 24 over 30, timesing it by 100, Jo got 80% correct. This last part here is fairly important too. The question was given to you in a sentence, so you must give your answer back as a sentence. Problem number 3. In a student survey, 80% of students said they received too much homework. If 300 students were surveyed, how many students felt they get too much homework? So let's highlight the important information. 80% of students out of 300 in total. And we want to know how many felt they had too much homework. So 80% is 0.8 as a decimal. We're going to multiply that by our total of 300 students. So that means 240 students felt that they got too much homework. Question number 4. At Lakes College, 10% of students walk to school, 25% of students catch public transport, and the remainder of students are driven to school. If there are 1,200 students at the school, find out how many students walk to school, catch public transport, and are driven to school. So highlight the important information. 10% of students walk, 25% of students catch public transport. And this one, although it doesn't have a number, there's still information there because it says the remainder of students are driven. And we have 1,200 in total. So we want to know how many walk to school. So we know 10% of students walk to school out of a total of 1,200. 10% of 1,200, or 0.1 times 1,200, 120 students. 25% catch public transport, so that's 0.25 times 1200. Now this last one, you could either work out the remaining percentage, or you could go, we had 1200 students in total, and we have 120 walking and 300 catching public transport, so we must have 780 left. Or you could work out the remaining percentage and say that's 65%, so 0.65 of 1200 is 780. I personally think that way is easier, but both are correct. Okay, 60% of the class answers 7 or more questions correctly on an exam. If there are 30 students in class, how many answered 7 or more questions right? So let's look. Important information, 60% of the class answered 7 or more questions correctly. And if there are 30 students in the class, so that's 30 in total, how many answered 7 or more questions right? So 60% as a decimal is going to be 0.6, and we've got a total of 30 in class, so 0.6 times 30 is 18. Okay, next question. Over summer, a dam's water, oh, just a second, I've missed something out there, haven't I? That question was given to me in a sentence, so I must give it back in a sentence. So if your sentence can be something easy like this, 18 students answered 7 or more questions right. So let's have a look at the next one. Over summer, a dam's water volume reduces from 20 megalitres to 4 megalitres. What fraction of water in the dam has been lost? So important information here is that it went from 20 down to 4. And the question here is, what fraction of the water has the dam lost? So it went from 20 down to 4, so it's lost 16 megalitres all up. So we're going to write that as a fraction, 16 out of the 20 in total, because 16 is how much it's lost. And you can simplify that down to 4/5. Remember, give it back in a sentence. So what fraction of the water in the dam has been lost? 4/5 of the water in the dam has been lost. Alright, Petrina for a recent class test scored 45 out of 60. Some important information. Malisha scored 72 out of 100. Use percentages to show that Ross obtained a higher mark. So that's what the question is actually asking us to do. That looks horrible. So 45 out of 60. We convert that to a percentage. So make sure, if you're having a bit of trouble, do that on your calculator. You'll convert that to a decimal of 0.75, which if you skip the decimal place 2 to the right, you get 75%. Do the same with Malisha, but her one is already out of a multiple of 10. It's out of 100 already. So 100 has 2 zeros. Skip 2 to the left. Actually, sorry, that's for a decimal. You can convert to a decimal first if you want to, it won't hurt. But that will just give you straight 72%. So who got higher? Ross or Malisha? Ross obtained a higher mark of 75%, whilst Malisha got 72%. Right, Greg, Maria, and David combined have $120. Greg contributed 0.4 of the total. 1/5 of the money is Maria's, and the remaining money is David's. how much money did each person contribute? Alright, so we know Greg contributed 0.4. So 0.4 times 120 is going to give us $48. Maria contributed 1/5. 1/5 is 1 divided by 5. So 1 divided by 5 times 120 gives us $24. And the remaining money is David's. So if we take away what Greg and Maria put in, that's 24 and 48. That leaves us with $48. So you'd end off with a sentence on the lines of Greg contributes $48, Maria 24, and David 48. Right, you can go to this website here, have a go at the maths conversion game. Make sure that you put in the capitals and the lowercase and all the full stops and slashes in the right place, otherwise you will not get to the right website, or it may not even work. And lastly, ask yourselves these questions and reflect on the lesson.